Hello everyone, welcome back to my video series. So far we have done the tunneling from there to there, and if we go to our branch, this is my branch. If you see, we have 4 tunnel in there. Network, yep, 4 tunnel is there, all the tunnel is up. And previously what we did from the DC and DR, we have published the same IP, and from this corp it's can reachable. But we face one issue, like when we down the one interface. So at that time it will take 3 minutes to transfer. So because the BGP actually wait 3 minutes to refresh its routing table and the BGP neighborship, because it's actually wait for 3 times 60 seconds. It will send 3 times that my neighbor is up or down, and if it find 3 times it's down, then actually it changes. Like, let me show you what's now about the condition. Ping 10901 -t. Yeah, we can ping it successfully. And if we, this is my 00 interface. So if we down this interface, it will come to actually my ISP2. From here to ISP2, using that tunnel, it should come immediately. But let's see what happened. Let's do that side by side so we can see. Yep, I'm shut down this interface, so my primary tunnel should go down and it should use the secondary. But what happened actually? Config T. Let's do a stopwatch thing. Oops, it's in clock. Let's open our clock. Okay, I think we don't have any clock in here. No worries, let's see the time. Time is 10:16. Interface geek 0 by 0. Shut. Yeah, at that time our, yep, it's the BGP is down, timeout. But if we go into our branch firewall, get router info BGP summary. This is my tunnel 10.7.1.253. It's showing still it's up. So when any traffic from there wants to go there in the routing table, it's saying still I can use that interface. Let's also show you the routing table. Get router info BGP network. Ah, crap. Sorry. See 10.901.0.0. This network still have the primary path. So we actually, because routing table decides where it should go. So it's seeing there is a route, so it's actually sending that way. But that tunnel is already down. Network. See, the tunnel is already down, but the BGP it's still established. 16. Let's see. Let's see when it's up. Actually, in 20, it should be up. BGP summary. Still it's showing up because of the BGP hold time. I know it's boring to watch. Yeah, just the BGP down. When it got down, at that time it have the now it have the best route for the secondary tunnel. 10.9, yeah, it's the best now. So there is a ping reachability there. So in the production, we don't want to wait 3 minutes because 3 minutes it might be small, but in the production it's actually big. Like you have thousands employee and thousands employee losing 3 minutes. That means a lot of time. So what we'll do, we'll configure BFD. BFD is actually like a feature that can reduce the hold time. So currently it's 180 second, but in the BFD feature, we will configure it for like 500 millisecond. Like in every 100 millisecond, it will check the BGP neighbor is up, and if 5 times concurrent down, then it will be automatically up. And then we can reduce 3 minutes to 500 milliseconds. You can do it more or less like 50 times into 3, like 150 milliseconds. But for here testing purpose, I'll do the 500 milliseconds. And when it come back, like ISP2 is down, let's turn on the ISP1. No shut. Yeah, our BGP is up. Let's see what is the tunnel summary, BGP summary. BGP is still down because I believe the tunnel is still down. Yeah, BGP just got up and it will exchange the routes. Still waiting to see the prefixes. It should receive. Yeah, within few seconds it will receive the routes because still it's receiving zero prefix means nothing it's actually receiving. Yeah, now it's receiving and our routing table should be the primary 10.9.0 this. Yeah, so the best route for this subnet is now our primary tunnel. So let's create the BFD and see what it's actually showing, like how it will react after the BFD configuration. So for the BFD configuration, I forgot all the commands, so you can just Google BFD configuration in FortiGate and there the document library will come. So for the BFD, first we need to create our profile, like which profile we want to create, like we want to enable it or disable it, like what should be the TX max, what should be the receive max, and how many times we want to check this. So this is a global profile, and in for the BGP, where is my BGP configuration? It should be somewhere in here. BFD in OSPF, yeah, BFD in BGP, and in the BGP configuration, we need to go to the neighbors and set BFD enable. Like we need to enable the BFD on that BGP network. So the total work we need to do in CLI because there is no graphical configuration. So let's start the configuration. So the global configuration, I'm copying it. I don't want to source port. Yeah, so I want to enable my BFD. Then my millisecond would be 100 millisecond each, like it fits within 100 millisecond. If the TX or RX doesn't received, it will think that at that time it will count that it's dead, and it will be checked by 5 milliseconds. So global configuration, every firewall, the global configuration is same. So let's configure admin, admin. This is my DR and the branch. So here from the CLI, let's paste, done, CLI, paste, and for the DR same. So now our every firewall have the profile for the BFD. Now we need to enable it in the neighbor. Let's do it. So for the neighbor, what is our command? Let's grab everything. Yep, this one. Oops. So config router BGP, config neighbor, edit our for the DC purpose. Like if we go to my topology in the DC, my neighbor is there is two neighbor for the branch. One is 10.7.1.1, 10.7.2.1. These two interface. And for the DR, we have 10.7.3.1 and 10.7.4.1 for this tunnel. Let's create the DC BFD first. 10.7.1.1. Set BFD enable. Tunnel 1 down and 2.1. This is my DC BFD configuration. Done, and I forgot the show command. Right, yeah, get router info BFD neighbor. Get router info BFD, sorry, BFD neighbor. For DC, we have two neighbor currently. This is our local address, this is the remote address, and BFD is down because we have configured in the branch end. So let's first finish for the DR. So let's copy this one. For DR, it's 2, 3, tunnel 3, and tunnel 4. Let's copy, paste, done. Get router info BFD neighbor. Get router info BF. Sorry, it's BGP coming. BFD neighbor. Yep, BFD is down. See, the whole time is 180 seconds. Keep alive interval is 60. That means 60 after each 60 second. It's normally the BGP normally done, but check. But for the BFD, we actually see how fast it is. Now let's configure our branches. It should be 1253 for the tunnel 1. 253 for the tunnel 2, 254 for tunnel 3, 254, sorry, 254 for tunnel 4. Actually, what I configured, 253 is for 10.7.1, 253 is for this tunnel using the ISP1, 253, 10.7.2, 253 is for the tunnel which we established with the ISP2, and similarly 3 and 4 is like same. So now let's paste and let's see how our BFD neighbor is currently looking like. Get router info BFD neighbor. Tada! We have 4 neighbors currently up. Let's see our DR. Yep, it's also up. Yep, all the neighbors are up. It's a pretty small configuration, but let's see how does it impact. So, yep, our ping is running. Let's make it short. So first of all, in the ISP1, so our tunnel is using this one. So let's shut down once again gig 00. ISP1, and we also want to see how's the ping status. And we need our branch firewall, because from here we'll see the route table and everything. Yeah, get router info. Okay, let's do a big debug. Get router info BGP summary. We'll see this, like how much time, after how many time this one goes, sorry, after how many times this one goes down. We'll check that, and we also see get router info BGP network. Oops, I think not neighbors, network. So currently it's using the primary tunnel. After, like, if any BGP goes down, it should take 3 minutes, but we configured the BFD, so it will be like 500 milliseconds. Let's turn down our config T, interface gig 0 by 0, shut down. So now previously we saw there is 300 millisecond downtime, but sorry, 180 seconds downtime, 3 minutes, but in here we just see 1 packet loss is there. Now let's turn off our DC firewall. So we should have backup from there, down, yep, there is up. So now it's using this interface, this tunnel. Let's verify. Actually, instantly it got down, and if we see our network, ten9 is using the third tunnel, and if we down that one also, like from the ISP, enable config terminal interface gig 0 by 0. So now I'm actually turn off this interface. Oh, 0 by 0 is already down. Actually, I should down that interface. ISP1 gig 0 by 1. That means let's turn off the also the ISP1. So that at that point it will have only this interface. This interface enable only. Shut down. Let's see our packet loss. Oh, why it's not sharing the routes? It shouldn't take that much time. Definitely I have done something wrong in the route map or anything. So if I see our tunnel, oh, I cannot see it from here because I turn off this router, so that's why it's down. Let's see from CLI, get router info BGP summary. Yep, number 4 is up. Get router info BGP network. 10.9, it's receiving the network. Obviously, I have done some mistake in the policies, I believe. I'll check that and let you know that what things I have done in the mistake. Otherwise, it should get the ping instantly. Definitely, I have done some mistake for the route map or anything. But this is the actually thing I want to show you, like that's the most I enterprise network do, and that's why we actually use our full redundancy and everything. Yeah, let's wait for the routers to come up and then I'll check. You can skip. Next on when the router come, I'll log into there using the GUI and check what was the problem. Hello everyone. Actually, I found the problem like when I did it in the routing map. Actually, I called the wrong prefix lists. Like if you see, where is my dear? See, it's up, the BGP is up, but it's not receiving any. So what was actually at that time happened? So it comes, corps come to the firewall. This firewall have the routes to go there, and when it hits the loopback and when it wants to back, because that tunnel doesn't know how to go to the corp, so that's the packet loss. So let's fix it. It should be our JDLab internal IP. Yep. No, it should be our DR branching. DR branching. Yeah. Apply. Execute. Router clear. BGP all soft. Summary. Need to wait a bit. Get router info BGP neighbor. Copy paste routes. It's not receiving routes. Receive routes. Yeah, receiving the routes. Receive routes. This. Why this one? It should be our 10.9. Like if we see the 10.3, tunnel 3 to 1. So from there it should be for one receive route should be 10 to 1. Let's go to the branch network routing object tunnel 4 DRPR out. Yep. So DRPR in. I have done some mistake in there. The branch also. Tunnel 4 DRPR in. And tunnel 4 should be our DRPR out. Lots of mistakes. That's why I hate the manual configuration. Execute router clear BGP all soft, and let's see from the DR receive routes. Let's clear the BGP. Still it's receiving. The receive route is not changed yet. Yeah, now it's changed. Routes. So let's create the scenario once again. So what was our scenario? Our scenario is ISP 1 down, DC down. So now we have only one thing from branch to our FortiGate firewall, and as usual just one packet dropped. Cool. That's the thing I want to show you today. In next video I will do the nets, like from here whatever the loopback I created, I'll do a net. I'll actually create some web server in the DC app. So I will hide that DC app server actual IP behind the loopback. So if any corp user wants to hit the loopback IP, it will actually reach to the app IP. So anyone from the browser type 10901, it will actually show the DC app web server. That I'll do. And hope you like today's video. See you in next video. Thank you.